Welcome back. I am Arup Basu from ClusterMicro Technologies. When your business logic detects an error condition, a bank account with insufficient funds, an invalid configuration, throwing a generic illegal argument exception with a message string is weak, right? It will not be very good. So it gives the caller no type information to catch and handle specifically. So custom exceptions can be caught specifically. They carry domain specific information and they communicate intent very clearly. Okay, so nothing is ambiguous about them, and it's quite clear. Let us check the code on how these are implemented. Okay, okay. So why custom exceptions, right? When your application detects a domain specific error, say a bank transfer where balance is too low, or configuration file with invalid settings, file missing, etc., you have two choices, right? You can throw a generic exception like illegal argument exception, insufficient funds, or you can throw insufficient funds exception, right? The second one is the custom exception. So the generic approach with illegal argument exception insufficient fund, it will work, but it will not have that information in depth, right? The caller will catch the illegal argument exception, and so does every other piece of code that throws illegal argument exception for completely different reasons, right? So the reason is not specific here, that it is because of insufficient fund, very detailed what is the fund balance, what he tried, etc., what will not be there, right? So the caller cannot distinguish insufficient funds from invalid argument from a catch block perspective. The custom exception approach gives insufficient funds exception its own type. The caller can write catch insufficient funds E and know specifically that they're handling a funds related problem. They can add domain specific fields to the exception like the amount attempted and the actual balance, etc. They can document it specifically in method signatures. So how do you create a custom exception? So if you see the top level class, we have created one custom exception here. Okay, so we have public class age limit exception extends runtime exception, then public age limit exception string message, and then super message, right? So we are passing the message back to the parent exception class. Is basically say we are creating this for a voting system where if the voter is less than 18 years, so he or she will not be eligible to vote. Okay, then how do we do this, right? How do we implement this exception class? So this is our exception, right? This is a what? This is our custom exception, age limit exception. Okay, so it extends runtime exception. So we then implement this, right? So we have public class voting system, public vote check eligibility, eligibility int age, right? If age is less than 18, then throw new age limit exception. Then age plus age is too young to vote, and else system.out.println welcome to the voting booth. Okay, so here what we are doing is that we are throwing new age limit exception. Age limit exception is what? It's our class, right? It was our custom exception class. Then what we are doing in the main class, if you see, we can have a public class main, public static void main, voting system equal to new voting system, and then we can call system.check eligibility 16, and then catch age limit exception E, system.a.println access denied E.get message, right? So this is how we implement a custom exception. Okay, so we have to remember a few things here, that checked versus unchecked, right? So checked is extends exception, right? The compiler forces you to handle this exception using try, catch, or throws. The caller can reasonably be expected to handle this condition and recover from it. Okay, insufficient funds, file not found, network timeout, etc., they belong to this. Okay, and then unchecked exception, that is extends runtime exception, the compiler does not force you to handle it. These usually represent programming errors or fatal business logic failure like invalid input, etc. So why use them, right? For readability, we can do throw new LinkedIn profile not found exception. It is much clearer to a teammate than throw new runtime exception, right? So that's why if you write a custom exception like LinkedIn profile not found exception, it's very much easy, right, to find it out, and then we can put like a name, age, etc., etc. So the exception will be very clear. And then we have specific catching. You can write a catch block specifically for your error without catching every other generic exception, right? And it is very clean code, so it separates what should happen from what to do when things go wrong, right? So 4 conventions the exam will expect you to know is that name ends in exception, right? So convention 1 is name ends in exception, okay? So all custom exception class names should end with exception, right? Insufficient funds exception, configuration exception, validation exception, LinkedIn not found exception, etc., etc. So this is a Java naming convention that the exam expects, right? And then we have convention 2, provide at least these 4 constructors. So the standard pattern for custom exception is to provide 4 constructors mirroring what exception itself provides, okay? So we have public, say we have public custom exception, then super, you're calling super. Then you have public custom exception, string message, super message, okay? Then you have public custom exception, throwable cause, super cause, okay? And then you have public custom exception, string message, throwable cause, then super message, comma, cause, okay? So following the convention of providing 4 constructors ensures your custom exception is just as flexible as Java's built-in ones, okay? So this allows other developers to pass messages, link the cause of the error, say exception chaining, or both, okay? So why these 4, right? We have, say, first one, right? Custom exception. So use this when the name of the class itself is giving enough information, like throw new unauthorized exception, okay? Then the second constructor is custom exception string message. It is the most common. Use this to provide specific details like throw new age exception, then within bracket age 16 is invalid, okay? Then custom exception throwable cause, right? So used for exception wrapping. If a low-level SQL exception occurs, you might want to wrap it in your custom exception to keep your business layer clean without losing the original technical error, okay? And the 4th point is custom exception string message throwable cause, the gold standard for debugging, okay? So it provides a high-level explanation while preserving the low-level stack trace of the original error, okay? So we are giving an example here. So if you want to see exception chaining, right? So it is the 4th kind of constructor example we are giving here, the public class data service, public void load data throws database connection exception, then within try throw new java.sql.sql exception, throw new java.sql.sql exception server timed out, and then catch java.sql SQL exception throw new database connection exception could not connect to the sales DB, okay? So why this matters in the exam? On the OCP exam, you might see questions about exception chaining. If you wrap an exception using the constructors above, you can later retrieve the original error, right? Using e.getCause. So if you don't provide the throwable cause constructor, the original error, the root cause is lost, right? Making debugging very impossible in large systems. So thanks for your time. See you in the next video.